This is Ken Small, SSA Architecture. Today we're going to do a little practice exercise for how to copy an existing drawing over to your CAD system. So if you have a printed drawing and you want to take it and put it on your CAD system, just what's the procedure? Now, you could be using AutoCAD or Chief Architect or Rivet or what have you, so I'm not going to talk too much about how to use the CAD tool. What I am going to talk about is how to make sure that you have a good, accurate copy of the drawing based on what you do on the paper. So here we go, down below. So we'll start here and we're going to talk about XYZ axis, right? X-axis, Y-axis, minus minus, plus plus. This is basic algebra from junior high school. So we're going to work in this quadrant right here. And this quadrant is the two positives. And so what we're going to do is we're going to start down here on the lower left of the drawing, and we're going to create a hypothetical 0, 0. And it doesn't necessarily have to work this way. There are some reasons why you might want to do it another way, but just talking about a basic rectangular building, then that's 0, 0. All right, now, when you're locating walls, everything is located off that point. So we'll start with a scale. This is a 3/16 inch equals 1 foot scale, which is a little bit unusual for an architectural drawing, but when it was drawn, that's what fit on the page. And now we're going to measure all the way across here, and we're going to get a dimension of the maximum distance out across the building. And so, not sure if that shows 100 feet 8 inches, and if we come out over here, this shows 105 feet 4 inches. Let me just make sure I have that aligned. Yep. So 105 4. And what did I say here? This is 100 feet 8 inches. All right, now from that you can draw a rectangle of the maximum size of the building. And so what do we need to know for the other dimension? We need to know the vertical dimension. So again, I'm going to put the scale on, which is much simpler because there's not innies and outies on the building from north to south. And here we come up with 87 feet. Should really be 87.0, so I don't confuse my foot mark with my inches. All right, so what I would normally do is I would draw a box this size. If you're working in BIM, then I would just draw the box with lines and not with walls, because you don't want to get mixed up between what are walls and what are layout lines. So you would end up with a box that essentially encompasses the whole building. Now, then we begin just working our way across from the known rectangle. So we're going to start here at 0 vertical, and we're going to go out this way, and we're going to find the dimension for the outside face of the first wall. And I would call that 12 feet 4. Now, carpenters have something they call set ahead and set back when they're laying out walls. And that means if you're a carpenter here, and I'm going to draw an elevation on a plan, which might be a little bit confusing to some of you, but there's the carpenter's head, and he's looking that way. Now, when you're taking your dimensions, if you're going to put your plate on the far side of the dimension you just read off, they call that set ahead. So I'm not going to tell you you need to do it set ahead or set back, but I'm going to tell you you need to be consistent, because if you don't, then you're going to get off. So we're not going to go from this 12-foot 4 wall location to the next one. We're going to go back to the beginning to 0, and we're going to take a dimension there, and then we're going to get exactly 24 feet. And then we're going to go to the next one, and I get 34 feet to 4 inches. 34, 4. And so on. So you're going to go all the way across, and at least in theory, when you get to the other side, you should again find 100 foot 8 inches. Now we're going to do the same thing vertically. So we're setting on 0 here, and we're reading the first wall. And again, I'm just assuming set ahead because that's what we did going the other way. So why change it and try to blow your own mind with do it one way one time and another way another time. So for that, I see 12 foot 6. And then going to the next one, I see 22 foot 6. And then we have this little jog around. That's exactly 24 feet. Okay, and then here we're at, I'm going to use a different ruler because the table's got stuff underneath the drawing, so to make it the scale lay flat, we'll switch to the smaller scale. And here we're at 39 feet 8. Okay, back on my face. So the reason why we're doing it this way instead of measuring wall to wall is so that you don't get cumulative error. This means that if you mismeasured one wall, just that wall is going to be off and not all the others. So if you do this after you've got those dimensions, then I wouldn't continue on with lines unless you're working in plain AutoCAD. What I would do is I would draw walls. So after you've got the big box, you can draw back to the drawing. You could draw a wall here and go up and just let it run wild on the end, and another wall here and let it run wild there. And then when you draw these intersecting walls, you can place them according to these dimensions that you've just taken. So there's no need to put all the notes on the drawing like I did here. That's just for me to explain to you how it works. And then once you have that with all the walls in it, you may then that would be the best time for you to put walls on layers that are related to what the walls are. So you might have one layer for exterior walls and one layer for interior walls. You might have one layer for new walls and one layer for old walls. I don't know, masonry walls, frame walls, whatever. I wouldn't fiddle around with what layer the wall goes on or what the wall is identified as while you're doing this. One exception would be is if you have a thick wall. So in this particular drawing, in the sample, these are all just shown as 4-inch walls on the original drawing. But say you had an exterior wall that was 12 inches, then I would, when I created that wall, make that wall the right thickness. And again, without wading too much up into the weeds of the total composition of the wall, what we're just talking about here is getting the plan copied. And part of the reason why we do this is if we're designing in BIM, then we can see what we've got in 3D. And if we're just doing basic design in plain CAD, AutoCAD, or generic CAD, or whatever CAD, then you can print out a drawing that's at whatever scale is convenient to you to design. So for instance, if I prefer to design at 1/8, or I prefer to design at a 1/4, but this drawing is at 3/16, then after we've entered in the CAD system, we can print out at whatever size we want. So what are the steps after that? So after you go around the drawing and you get all the walls in place, then you're going to pick up other things that are in the built environment that you think you're going to have a use for. Now, if you have plumbing fixtures as an example, then again, I would draw them after you get in all the walls, and even if you don't intend to keep them, probably just move them to a demolition layer, because you're probably going to need a demolition drawing eventually. But a lot of these things aren't decided when you start just copying an old building to remodel it, which is really the kind of scenario that you would do this in. And so it's not really a good idea to try to ignore any information that you have in the original drawing, because you never know what's going to be important to you later on when you're designing. So this kind of work is usually done by entry-level staff, and then later on it'll go on to the designers. And if you're a student and you're trying to learn how to do this, then this might be one of the first things you're assigned to do in CAD, because usually the principal architect or the design architects will assign this to somebody else as they begin with the design. Now, in our firms, sometimes we just draw on tracing paper, butter paper, or white trace, and so you can just scribble on top of the... This is Ken Small closing for SSA Architecture in Las Vegas, Nevada. We're at 7040 Laredo Street. Our phone number is 702-873-1718. Do remember that possession of a CAD software is not the equivalent of 5 years in architecture school and a 3-year internship to get an architect's license. So if you're an individual and you're doing this, great, more power to you, but just keep in mind you don't know what you don't know. Have a great day.